Hello students, so this is a question from CPU scheduling, okay, and it's a 2 marks question. So the question is, given a process scenario as follows. So we are given with 6 processes here with their arrival times and with their burst time or the run time, and the question is number of context switches if round robin scheduling algorithm is used for scheduling is dash. Okay, so what we want to find is, we want to find number of context switches if we use round robin scheduling algorithm. Okay, and time quantum q equals to 2, so we have to consider time quantum q as 2. Okay, so let's start. So there is this chart which is already here, so let's see how we are arriving at this chart. Okay, so at time 0 there is only one process P1. Okay, so we'll start with P1, and because q equals to 2, we'll run process P1 till 2 time. Okay, so P1 will run from 0 to 2. Okay, now during that time there are other 2 processes P2 and P3 which are arriving. Okay, so P2 and P3 will go into my ready queue. Okay, and they will be waiting for the CPU. Okay, now as soon as this P1 gets complete, P1 will join this particular queue. Okay, so this is the head of my queue and this is the tail of my queue. Okay, so process I will take P2, so I will take P2 for scheduling. So P2 will come here, it will run from 2 to 4. Now within that 4 time there are 2 other processes which are coming. Okay, P4 and P5. Okay, so P4 and P5 will join this queue, P3, P1, P4, P5, and after this process gets over, that will again join the queue. Okay, so this is the head of my queue. Okay, so we are left with 2 units of this process and 3 units of this process. Okay, so next there is this process P3. Okay, so we'll start with P3 now. So P3 schedule here. P3 will run for 2 units of time. Okay, so within that time there is one more process P6 which is arriving. So I have now P1, then P4, then P5, P2, then now we have P6 which has arrived, and once this P3 is over, P3 will also join this queue. Okay, so this is the final sequence. This is the sequence in which we will execute these processes onto the processor. Okay, and we are left with 4 units of P3. Okay, so we have executed these 3 parts till now, P1, P2 and P3. Okay, and this is the final sequence in which we will schedule our processes. So there is at least 2 units of time is remaining for all these processes. So we'll schedule these processes in this sequence, P1 followed by P4, P5, P2. So P1 followed by P4, P5, P2, P6 and P3, P6 and P3. Okay, so each of these processes we are running this process for 2 units of time. So after running till here, we'll be left with 0 units of this, 1 unit of this, 2 unit of P3, 1 unit of P4, 0 unit of P5 and 4 unit of P6. Okay, so P5 and P1 are already over, so we'll remove those P1 and P5 from this queue. So currently our queue is P4, P2, P6 and P3. Okay, and we are left with this units of work or this units of runtime. Okay, so we'll schedule P4 next. So P4, the runtime, remaining runtime is 1 unit, so we are schedule P4 here. Okay, with runtime of 1 unit. So there is this 19 here. Okay, so this P4 is over now, so the P4 is 0. So after P4 we will schedule P2, so we are left with 1 unit of P2. So we have done P4, now P2 will be scheduled, so it will run for 1 unit. So 19 to 20 P2 will run. Okay, after that, so these 2 processes are over. After that there is this P6, so this is also over. So after that there is this P6 which will run for 2 units of time. Okay, so P6 will run from 20 to 22. Okay, and because there is time quantum q equals to 2 and P3 is there, so we'll run P3 for 2 units of time. So we are left with 2 units of this. Now we are running P3 So P3 will run from 22 to 24. Okay, so this will become 0, and at the end we'll again run P6 from 24 to 26. Okay, so this will also become 0. So we have successfully scheduled all the processes. Okay, so let's count the number of context switches. So this is the context switch number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Okay, so the number of context switches is 13. Okay, you need not count the last context switch. Okay, so the data of P6 will also be saved here at the end of P6, but you need not count that last context switch. So the number of context switches are 13. So 13 is the answer. Thank you.